Thank you very much. So I want to acknowledge first Aubrey and Siripon Jintapong. I don't know if I pronounce your name properly, but there. And who really collected all the data we are presenting here shortly, and that's really a common work. So electronic recycling, in fact, has been pretty well studied in terms of life cycle assessment of products. And I have a colleague in Switzerland, that's where I'm from. My accent is from there. Which have been looking in detail, but more in the I would say industrial recycling side. And Switzerland is a place where I mean the highest recycle rate in Europe, in fact, there. But there is little quantitative data for the informal sector. We need also to combine what are the environmental avoided burden when recycling with the socio-economic and also the occupational risk that people can have. So our goal was to develop a method and building from the nice introduction we just had on how you dismantle. We had worked already, that was in India, in fact, on glass bangle that we did and started to combine these different things, looking, in fact, at the CO2, at the megajoule, at the rupees here, the financial, and who was working on that. So building on that, the first thing is when we want to have a product perspective. Well, we look at one product, and here we have a TV, and this is how your TV is dismantled, from plastic, the wires, your printed circuit boards, the cathode, and they really take care. In fact, it's interesting to see that here the waste is like 64% here. It's still substantial, but for other pieces, we really limit the waste, and they try really to get profit from everything they can in there. So the first thing is to make a balance, and our colleague in Thailand bought different scales and put the equipment, and you want to check that, in fact, your initial weight that you have here, the starting mass, correspond to your material composition. I can tell you the first 4 we did, it was not the case. Now it's nicely done, and very thankful for the nice work which has been done on that. And you see the composition here, the screen is a big part, then you have your plastic, which is high, and copper, in fact, we're speaking here of small mass in the end. But when we look at the price, it's about 175 baht per kilo copper, against about 7 for the steel. So it's clear that this quantity of copper, which are limited, will start representing an important income. And when we multiply them, we see that, in fact, the copper is more than half of the probability, the plastic and the printed circuit board being the rest here in terms of income. And it's interesting to see that it's about a profit of 30% between the purchase price, which is, of course, probably adapted to what people can get out of it in that case. And we see that the total profit here is about 30 baht. Now, it's interesting to say how much are people paid. We were saying about 40 baht an hour as a salary. And so it means you need to do several of these, okay? And we were also looking at, in terms of socio-economic, to look what is the time for each of these separation. And you can see for dismantling, here we were speaking about 8 minutes for one TV. Some people, on the quantity of material, the income, there is very little difference between people. But when we look, in fact, at the time, then we have a factor 2 between someone who is working very quickly and someone else there. So we see that if it's 8 minutes, I mean, you could do like at least 5 TV in an hour. Times 30, you have 120, 40. It really makes sense in terms of the consistency between the economic. Now, you could also look what energy you're recuperating, because when you are recuperating aluminum, you're from the 160 megajoule per kilo aluminum for primary aluminum, in fact, you're saving 175 or 155 in that case. And so you are avoiding, and here it's very different. You see copper per kilogram is not super intensity of energy and CO2 against here aluminum. And you see that for the TV in terms of environmental side, copper is not that important, in fact, but the plastics start to be important if you can recuperate it really and produce new plastic with it. And potentially the printed circuit board, but here the data are very uncertain in that case. But that's what we can substitute for the environment. It's not necessarily the same as for the profit, which is interesting to notice here. Washing machine recycling, if we looked, it's a similar story, but here the steel is important. We start having a substantial part of steel. Again, the copper is about half of the income in that case. Also a profit of about 30%, but the total purchase price is twice the price of a TV. But profit will be also about twice here. And time is also about twice. You see that's consistent, 20 minutes here to dismantle it and get your steel and your motor in that case. We also did the refrigerator and the fan, which are the main things. Now, how do we combine all that? And that's where math and matrix approach can be useful. Basically, you see per product, you can say, this is so much % of the different component or material we can get out of that. And let's take, that was one real factory there in Thailand. They were processing 100 fan per week, 7 refrigerator, 10 washing machine, and 45 TV. That's how many kilo of material, of the incoming material they are processing. So about 2 tons per week of material they were processing. And when you combine that with the price, you will get, in fact, their income from the different, here in baht per week, from the different material that you have. And you could also get the avoided energy associated with the material and get the performance that you have here. And then I can get back to my engineering colleague and play with that to say, how could we optimize that? How could we improve? But we start having the metric to do that in that case. Now we want to look at the occupational health. One is, in fact, the emission we published before, in fact, I came here in 2006 here. We published the emission, in fact, from burning. That was a printed circuit board from a phone in that case. And you see emission from arsenic, cadmium, lead, and selenium here in that case. Now, for injury, the idea is to say now, in fact, what we want to be able, once you have the minutes spent for each item or per item, Audrey has collected about 100 different workers and their risk of injury. And apparently on 100, like 2/3 have had injury in the last year. So it is substantial. And we can start linking, in fact, also per our work, what is the risk of injury, and again, looking at best practice, how we could reduce that and mitigate that. But it means we can combine really in the approach the environmental and socio-economic consistently. We can combine the occupational and environmental side. And we saw that LCA is usually on a product basis, but if you start looking at the flow of product there, you can do a mass flow analysis and look at the company level or change the boundary. So it's nice, if you like, once you have your core per product emission, then you can really play with it and on different dimensions, which is pretty nice, and start mitigating risk. So let's play with the tool, but let's try also that it's useful and use it. Thank you.